Lesson 21 is looking at interpreting graphs of derivatives. So we'll just start with a graph. F prime of x. Let's say the graph looks something like this. Okay. So we know our critical numbers are going to be where f prime of x is equal to 0. So critical number, we have 1, x equals 0. We can also find when it is increasing. It is increasing when it is positive, decreasing when it's negative. So negative infinity to 0, decreasing from 0 to infinity, right? And then we can examine our relative maxima. So if you think about this, it goes from increasing to decreasing. So we're going to have a maximum where it changes. That's going to be 0. Maximum at x equals 0. And there's no minimum. There's none. We can also find the concavity. So find when it's concave up and down. So if you just think about the derivative, what the derivative of this graph would look like. This graph, the slope is always negative. And we go back, we know that concave down, it's concave down when it's negative. So this graph is always concave down. And since it's always concave down, it's never changing concavity. Therefore, there are no inflection points. Let's take a look at another graph that we might see where f prime of x looks something like this. Okay. So again, we can find our critical values just by finding where y is equal to 0 or f of x is equal to 0. So that is at negative 2 and 2. It's always increasing because it's always above the x-axis. So negative infinity to infinity. Decreasing. It's never decreasing. This graph is not going to have any relative maxima just because it does not cross the x-axis. We can find the concavity. So I know that it's concave up from negative 2 to 0 because it's increasing. And 2 to infinity because, again, it's increasing. And decreasing from negative infinity to 2, negative 2. And decreasing again from 0 to 2. Now the concavity does change here, so we know that we have inflection points. X equals negative 2, 0, and 2.